Okay, hi everyone. I make that 5 o'clock in the UK, so I guess we're ready to start. So welcome to the Neo4j online meetup. Today we're going to be looking at how we can build a Wikipedia knowledge graph in Neo4j. So my name's Mark Needham, so I work on the developer relations team at Neo.
And I'm Jesus Barasa, and also part of the developer relations team.
And the session that we're going to run today is actually based on a series of blog posts that Jesus has been doing, called the Quick Graph blog post. So I'm going to post a link to that in the chat. But before we get started, I'll just do a little bit of housekeeping. So just give us a sec. Okay, so hopefully you've got the slides now. So just a quick bit of housekeeping. If you've got any questions, we've obviously, I see a few of you have already identified that we've got the YouTube live chat on the right-hand side. That chat only lasts for the duration of the meetup. So if you've got other questions that you think of and watching this afterwards, put those on our Neo4j Slack account on the Neo4j-online-meetup chat, and one of us will watch on there, and we can answer those. Another common thing that we've seen in previous meetups is that sometimes when we're showing code, it looks a bit grainy. So if you're having problems with that, at the bottom of your video, you should be able to set the resolution to 720p, and then that will hopefully solve those. We're both watching the questions, even though we're presenting as well, and Alex Erdl, a colleague of ours, is watching as well. So he'll send any questions that we don't spot our way. So if you've got any questions, ask them whenever you have them, and we will pick them up when we see them. And with that, we're ready to get underway. So I'd imagine probably most of you have seen Wikipedia. I hope so, at least. And this is so we're a bit self-referential here. This is the Wikipedia page of Neo4j, and at the top of the page, there's obviously a load of text that kind of explains what Neo4j is. There's a little bit of information on the right-hand side. But the really interesting thing in terms of what we're going to look at today is actually at the bottom end of the page. So if you look at the bit highlighted in red here, we've got, so we're on the Neo4j page still, and we've got some categories. And you can see there are lots of different categories, and there are all different levels of granularity. So there's one saying, hey, this is a graph databases. There's structured storage. We've got the more esoteric software companies of Sweden, and then there are some licensing specifics, so software using the GNU AGPL license. Then there's a database software stuff. But so you can see there's lots of different categories in there. And if we zoom in on one of those categories pages, if we, for example, pick the NoSQL page, so we zoom in on there. You can see that that's actually got now some subcategories. So we've got the NoSQL category, and then that's got two, in this case, subcategories. So it's got NoSQL companies and NoSQL products. And if you look at this just the right way, we've got a bit of a graph. So where we've got NoSQL at the top, and it goes down to NoSQL companies and NoSQL products. So that's cool. So it's a pretty simple graph. There's only three. So we've got in this graph, in case you haven't come across Neo4j before, we've got three nodes. So we've got one representing NoSQL, one representing NoSQL companies, and one representing NoSQL products. And then we've got some relationships, although we haven't actually named those yet. But we'll get to that once we get into the Neo4j side of things. But we've got a little hierarchy. If we scroll down the page even further, so if we go right to the bottom of the NoSQL page, that's actually got categories as well. And so these are the parent categories of the NoSQL category. So these are it's parent categories, and so you can see they're a bit more generic. So it's data management, databases, and structured storage. And we can do our same trick there. And now we've got a little bit of a even more complicated graph. So we've added in three extra nodes. We've got data management, structured storage, and then...
So yeah, basically what we see is that the pages in Wikipedia are organized kind of in categories, and then categories are organized in a huge hierarchy, a taxonomy. So you sometimes think of a taxonomy as a tree, like a category that's subdivided in subcategories and so on and so forth. thing is, in Wikipedia, it's not a tree at all. I mean, in this small fragment that we've seen, we see that a single node can have multiple parents, so it can become quite complicated. So it's organized according to many different dimensions, and analyzing it and exploring it can be quite interesting.
Yeah. So actually, yeah, exactly. So we can actually see that a little bit if we continue with our manually constructed graph. We can actually see a little bit of what Jesus just mentioned on this diagram. So you can see that NoSQL has structured storage as a parent and data management as a parent, but structured storage also has data management as a parent. And then the same thing for databases. Databases is a parent of NoSQL, but it's also a child of data management, which is a parent of NoSQL. And as we go through and load in more of data, we'll see there's actually some places where there's actually loops in this taxonomy.
Yeah, so it's I mean, it's not a strict hierarchy. It's a multi-dimensional way of organizing the information, and there's all sorts of interesting patterns, as we're going to see when we load that into Neo. Yeah. And the thing, as you've seen while Mark was exploring it, is that these categories are kind of hidden in there. So we typically go to the Wikipedia and we can navigate, we can click on one category, go to the parent, but there's not a way of looking at them in a more structured way, to like run queries or analyze them in a more structured way. That's what we're going to try and do today. So.
Yeah, and I suppose the other interesting thing, which was surprising to me, is I thought, oh, if it's a category-based data structure, it's probably going to be a tree. Like, it will probably be I can follow one route all the way down, and it definitely isn't from exploring this data set. Okay, so at the moment we've got a manually constructed graph of a little bit of Wikipedia, but that obviously, as you've probably. Maybe you're feeling the tiredness already. It's a bit cumbersome having to we've done a slide-based click-through, but we did this manually earlier, and so it becomes a bit tiring to try and figure out. Oh, I just want to see what are the categories around NoSQL, and we've got to click on. Especially
if you think of the fact that there's actually around 1.5 million categories, so it would take quite a while.
That's a lot of clicking. And so helpfully, there's actually an API that we can use to access this. So we've got if you want to have a look yourself at the bottom of the page, it's on the Media Wiki, but we're gonna go through it on this session. So if we have just a quick look, what do you actually get? So here on the right hand side, we've constructed a query against that API, I suppose. Yeah. And the main thing to be interested in here is what category we're looking at. So there's two kind of interesting things here, and they're on lines 4 and 5. So we've got CM title, which is where you indicate the name of the category that you want to look at, and all of the URIs. I didn't point it out, so it might not have been obvious. They all have category : as the prefix, and then the name of the category. And then so there you can fill in anything. So you could have filled in any of the ones we looked at. So we could do category NoSQL, category databases, category storage management. Was it storage management? I forget which one it was. And then the next argument that we're giving is the list one. And that's category members means show me the subcategories.
I mean you guys can probably have a look at the documentation. So this API will give lots of information. So for a given category, you can get a kind of a description. You can get the parent categories, the child categories, and what we're going to use it for is to get the child categories, and that's what we get by using the category members value in the list. So
I think now, we're gonna go away from the slide temporarily. I'm just gonna quickly show you what this looks like. So I'm just going into the normal browser. Hopefully this is big enough. As Alex has pointed out on the comments, if this is too small, it's a bit blurry, try the 720p resolution. So hopefully I've got this zoomed in enough that you can see it. And this is what it looks like for the category types of databases. This is what you get back, and if I just scroll down a little bit, you see we get a JSON structure back. We've got a key batch complete. In this case, we're just going to ignore that. That's not very interesting for this. But then underneath, we've got a field query, and then underneath that, there's a field category members, and those are the subcategories of types of databases. So if we scroll down, we can see you get back a page ID. So that's I think that's probably an identifier for the category. I don't know what. Do you know what NS is?
Yeah, it's a namespace. I mean, there's plenty of information that we're probably not going to use for this example, but yeah.
Yeah, so we get those two back because we said we wanted IDs. And then if we go down, so we've got big data, we've got blockchains, then there's a few more generic ones. So we've got types of databases. We can go down. There's 13 or 14 different ones. And if we wanted to manually do what we've just been doing from the Wikipedia pages, we could actually just copy that there. So for example, here I'm going to copy blockchain. So I just select the blockchain title and I go into the query bar. It might not be so clear, and I'll just paste that in. And now we get back the blockchain category, and it's got a subcategory Ethereum, which is a type of blockchain, and so we could do the same thing there. We could do that one, and now we've actually reached a leaf node.
Yeah, exactly. So yeah, eventually by keeping drilling down, you'll get to a point where a category does not have any more subcategories, so it's not further subdivided, so we'll only have a few pages probably. But yeah, exactly what Mark has done now manually is what we're going to reproduce then in Neo. So we're going to pick a starting point and then incrementally bring levels of subcategories based on this starting point. So yeah.
Okay, so we're just going to quickly switch back to the slides temporarily just to show you how you can follow along if you want to. So we're gonna do the first part of this demo from the Neo4j sandbox. If you the sandbox allows you to create yourself an online like a hosted instance of Neo4j. So if you go to neo4j.com/sandbox, and in this case we're going to create ourselves a blank sandbox, and we'll then be able to run queries against this Wikipedia API, load it into Neo4j, and then do some Cypher queries against it. So if we'll just zoom back out into the browser again.
Okay,
so this is what you'll see if you go on the Neo4j sandbox. You'll get a login button. You can then log in, and you can create a sandbox with some preloaded data sets. Although in this case, the one we want is actually the one that says blank sandbox. And if I navigate over to tab number 2.
Yeah,
this is where we've got. This is one we've created earlier. So Alex has put the link into the notes if you want to follow along. And most of this is going to be a guide, and we'll put the link for that in a second. But let's have a look. How would we explore this to start with? So on my favorites, if I zoom in a little bit, I've saved a query. And if I just I'll just minimize that and zoom in a bit so you can just see what we're doing. So we're using the APOC library. This is awesome procedures on Cypher. So if you launch a sandbox instance, that comes preloaded. If you're doing it on a local instance of Neo4j, just search for Neo4j APOC, or I can put a link in the notes as well. And you'll just need to put the appropriate jar into your plugins folder. But on the sandbox, it's already installed. And what we're going to do is we're going to call a procedure in there called apoc.load.json. We're going to feed in this is a dynamic URI. So most of this you're going to be familiar with. This is exactly what we had on the slide. The dynamic bit is in here where I've got highlighted now. So this is the category, and so this is a parameter. And so I'll just quickly show you how do you see what parameters you've got. So in the browser, so right, so at the moment we haven't got any parameters, but what we can do is we can type :param category :, and then we'll just pick
databases.
So we'll do databases, okay? So that's one of the high level categories, and if we just execute that, and then if we run the command params again, now we've got a category called databases. Now, if you're running these, this is the equivalent to running a query from one of the Neo4j drivers, and if you were running it from there, you'd be passing in a map of parameters. So this is a way of doing that.
Kind of manually simulating that.
Manually simulating that. So what we can do now, I guess we can, that's a pretty good idea. So I've lost the query, hang on, I've got it on the clipboard though. So if we paste that back in and we run it, then we get back, I made a mistake, and now I forgot to put the category, so we need category code at the beginning, don't we?
Yeah.
So if you do that again, so you need category code at the beginning, so I forgot that. You see, you get back So we've got batch complete in there. You'll remember that from the top of the page. If I just browse over here, so this is what we're parsing. So this is the raw. So we've got batch complete, and then we've got. So we'd also expect to see query and category members in there somewhere. So I just navigate back, and I'll just scroll down a little bit. So the output of load.json is maps. There's maps within maps within maps. And if we scroll down enough, we'll find that there's a query query key. So there's the query key. And what we can do now is, so what we did so far, so we said call apoc.load.json. We gave it the URI, and we said yield value, and that gave us back the result. On that value, we can now say, actually, I don't care about that batch parameter. What I care about is query. So we'll just return that instead. Okay, so now we've got, you can see it's still a little bit indented. And the reason for that is because we haven't quite gone all the way in. So we've got to go into category members. So that's where all our result really lives. So they give us a bit of a nested structure, but Cypher makes it very easy for us to navigate in. Okay, so now we're all the way in. So, but at the moment, we've got an array. So we've got an array of the subcategories of databases. And so if you just browse them, so databases by continent. Wow, that's quite. So databases by continent, databases
category, by yeah. So these are the different ways in which databases are categorized in Wikipedia. So in some cases might be a bit weird for us, but yeah, these are. So all of them are categories that you can go and browse on the Wikipedia and find pages in each of them.
But if we want to interact with this in Neo4j, we really want to be able to interact with each element individually. And so, for example, we might want to go and create a node for each category. And so there's a command called unwind, which you might have seen. So if I put a Q in there, we can unwind an array and get an individual item for each thing that's in the array. So it's quite simple. So we just, instead of returning value.query.category members, we just prefix it with unwind. We then alias each value that's been unwound. So in this case, we know that each one is a category, and then we'll just return it back to the browser again. And if we run that, now we've got one row per category. And if we browse down, these are, I mean, the data is exactly the same. So we've still got all our databases.
And now we could pick these. That's what we're exactly going to do in the query in a minute. But we could take each of these items in the list and run a create.
Yeah, so we could say, hey, I'm going to go and create a node. I'm going to put the category label on there, and I'm going to give it a name. Or there'll be a title with it. Title category. I guess we could run that. Oh, not so happy with that. Can I do? Oh, yeah. Sorry, I forgot to take the. So I want to actually grab the title rather than you can't put the map on there. So actually, you need to go and grab the value. And if we do that, we get 26 labels, 26 nodes, 26 properties. So we've created the subcategories of databases. We can go down. We can here, and if we just where's it gone? Right. So we'll just put it as title, and so now we've got database companies, we've got online databases, and we've got database normalization. And you can also, so this is the graph view. You can also have a look at a row view, and you can see everything that we've created. But actually building the Wikipedia hierarchy or taxonomy is a little bit more complicated, and so we've created a guide to do that. Just a little bit.
Shall we clear that?
Yeah. So we're gonna. Right, so we've got a question. Does unwind do destructing? I suppose it's doing. It's more unpacking. So if you've seen there's another Cypher command called collect, where you can have if you have a bunch of rows and you say I want to collect on a particular node or a particular property, it will give you an array of those. Unwind is the opposite of that. So it's like I'm starting with an array of values, explode it out so that I get one row per value in that array.
Do we go back to the slides, or are we?
Yeah, so we'll just go quickly to the slides, just so you can, in case you're following along, you can see what we're going to do. So what? Yeah, I guess you could.
Yeah, no. What we're going to do right now is basically automate what Mark has shown you right now. So we're going to create a portion of this hierarchy in Wikipedia and in Neo. But instead of having to type, because it becomes a bit more complicated, instead of typing all the queries, what we're going to use is a guide that you can run by typing these in the browser. So if you the colon play and this URL, you will get on your browser, on your Neo4j browser, this screen down here, and then from there we can click on the queries and run it very, very easily. So that's what we're going to do. So if you want to play that along, in case you have either a sandbox or a Neo4j instance in front of you, feel free to play it, and you can see the results at the same time as we do.
Yeah, I'm just going to put that in there for you as well. So right, so there we go. That's in the chat.
Good. Okay, so let's go back to our instance. I think we have the link here. So if we play, do we have to keep it big or? So if we run the guide, you should see something like this. I don't know if it's readable. Should we make it a bit?
Yeah, we can probably make it a little bit bigger.
Bigger, good. Right. So basically, the first page of the guide describes the process of loading into Neo4j reduced portion of the Wikipedia hierarchy of categories. So we said that there's like 1.5 million categories in there. We'll look at how to bring them all into Neo later on, but this first approach, what we're going to do is exactly what Mark did before. So let's say we want to analyze a portion of the Wikipedia. For example, we just want to know about databases and how they are structured in the Wikipedia. So what we will do is we will select a root category, which is the one we're going to expand and to build the graph around it. And then we are going to incrementally load child categories up to level n, and it will be up to us to decide. So what you have here is, step one is just preparing the database. So just to make data insertion and data querying a bit faster, we can create a couple of indexes. I've done it already, so I'm not going to run it again. But basically, on each of the queries in the guide, you just need to click on them, and it will go up in the query side, so you can run it. So once we have the indexes created, what we can do is, well.
So I guess one thing, so that you'll know that you've done it, or that it's worked correctly. You can always type colon schema, and it will give you an indication of what indexes you have. So I guess for anybody who hasn't used Neo4j before, why are we creating the indexes?
Yeah, well, the indexes have a completely different purpose as the one they have for example, in relational databases. Indexes is just a way of giving you fast access to the starting point of your traversal, right? So this is, if in our case we're going to be looking up categories by ID or by name, it's useful to create an index so that these searches are fast and performant. But then from there on, what we're going to do is traversing relationships, which is what Neo4j excels at.
Cool. Okay, so we need to get our root category into the
database. The one that I was thinking of using is probably databases. So I'm going to manually.
Yeah, so that was the one we looked at, wasn't it? On the
exactly. But what I'm doing is I'm creating the first category, and what I'm doing here is I'm giving it two labels. So the first one is category. Every category is going to be labeled as category in Neo, but also I'm going to label this one as root category. There will be only one. And I'm manually giving it an ID of 0. That's not very important. It just has to be unique. That's it. And the name. And we're going to see these two indicators that I'm going to use. Fetch this just tells us whether we have retrieved from the Wikipedia API the child categories. So it's set to false by default, but we will set it to true once we've retrieved the child categories for it. And then level is basically the distance, the minimum distance to the root level. To the root node, sorry. And since that's the root node, the distance will be 0. So if we run that creates a single node. So we can see that we have only one node in our database. So that's the root node. Again, we're going to set as the default the category name. So it's databases. And then from here, what we're going to do is incrementally load new levels. So again, we can probably have a look at this query, maybe in the guide. I don't know which one will be more. But basically what I'm doing is exactly what Mark did before. So we're going to generate a call to the API pretty much in the same way, right? So with the same URL that Mark was using before. The thing is, what I'm doing is first I'll look for the categories of a given level. So it will take a parameter as input. We're going to set that parameter in a minute. And for all the categories in that level, we're going to run each of them. We're going to run a request to the API. that will return results, where we will be unwinding it exactly in the same way we saw a minute ago. And for each of them, we're going to create a category. So we're using the merge as opposed to create. It's not used before, because merge will do create if that category doesn't exist, but it will reuse it if it exists already. And we'll set some parameters. So we'll get the category name, and we'll mark it as fetched false. By default, whenever we create a category, we set it as false, and we'll mark the level as the distance to the root level. And then what we're going to do is I'm going to use another function, this is actually a procedure actually in APOC that will set dynamically an extra label on my category, indicating, labeling it as level 1, level 2, level 3. And that's going to be useful for visualization, as we're going to see. So if I try to run this, well, first, if I run it, it's going to ask me for a parameter that's not defined yet. So I have to define level. So if I set level to 1, I want to load level 1, and I rerun my query. What's going to happen is that basically my cipher is going to generate 26, one request to the API.
So that's the same as the ones we got before. I think
exactly.
It was 20.
The thing is, each subcategories that we've created, if you look at the cipher here, is going to be linked to the parent category through the subcat-of relationship. So if we look at the graph, we see a bunch of categories that are linked through the subcategory of relationship to the databases one, right? So all we have to do is run this as many times as we like. So we're going to go for level 2 now. And again, we're simulating here what in a client application we're doing by setting a value for a parameter. So if I run exactly the same query again, the same I did before, but now with then the parameter, now it's going to bring 124 nodes. So we can have a quick look at that. And we see that I'm going to remove the limit to make it more interesting. So we see that the graph is growing, right? So we have more and more categories, all starting from the root one, which was databases.
Oh, wow. So we're going out. We're going out 2 or 3 levels now?
We've gone 2 levels. We can probably go up to 4, I reckon, to create a reasonable data. So set it to 3 and run it one more time.
If you were doing this from a programming language, I guess you could put it in a loop and go, okay, I'm done with level 3, now do level 4.
Exactly. So, like and we're probably going to do the same with level 4, and we stop there. That's probably enough. So we set it with level 4. Keep in mind, I mean, this is you will use this approach only for a reduced portion of the hierarchy of categories. Keep in mind that for every category that you expand is issuing a request to the API. So in each of these cases, we're probably running 100 of them. So you wouldn't run, that if you want to bring the whole hierarchy into your database. So that's it. So we have up to level 4. So I think that's reasonable. And again, we can have a look at this in the browser visually. So it's limited to 300. We can probably stretch that a little bit. So we can probably show up to 1,000 maybe.
Chrome is not happy with you.
Yeah, it's not going to be happy, but I think it's going to be interesting.
So probably put it full screen maybe.
Yeah. I was just trying to close because that keeps. Okay, so that's down to level 4, and we can zoom out a little bit. And the trick of the labels is useful here, because now we can do something like this. So we can say, okay, we're going to mark our root category as in red. So we see that our databases is in there. We go level 1, we can make them, for example, pink. So we have all the level 1 categories, so all the direct subcategories of databases. We can mark level 2 as in green, for example, and level 3 in yellow, and leave the level 4 in blue. Well, anyway, so we see that with 4 iterations, we've created, well, still a small graph, but it gives us an idea of what the hierarchy in the Wikipedia looks like. And well, we can probably pass the mouse over some of them, but you see that we have
legal citators, that one.
Yeah, you have GitHub there, so it would be interesting to see what the connection is between GitHub and
what's the parent of GitHub?
Well, GitHub has open source software hosting facilities.
Nice. Okay.
Yeah, that's probably an interesting one. Let's remember GitHub, because we can write a query and try to find what's
who's its sibling?
Discontinued open source.
Wow.
That's another category.
So there would be another one if we did level 5.
Yeah, so you'll find all sorts of IBM DB2. So you have a Sybase. Okay, well, so that's the graph we're going to work with, and you can easily construct it in your.
So we've got a question from Adam Cowley about could we use range or unwind to run the query that we just did manually for multiple levels?
I guess you probably would need to put it all in a sub query. It would need to be on APOC.
Because level 1 was relying on level 2 was relying on level 1 happening first.
Not in the same transaction, probably. It has to be separate ones, I guess.
Yeah, there might be a way to do it. We'll have to.
Well, yeah, we'll leave it to you can give it a try.
There you go, a classic exercise.
Volunteer.
Yeah, so if you can figure out a clever way to do that, the code is always there. Okay, so what are we doing next? So
let's explore a little bit of what we've loaded. So what I've done is I've run this query that looks at the biggest categories in the set that we've loaded. So what I'm doing is, well, for each of the categories in my data set, I calculate three numbers. One is the size of this pattern, which basically gives the count of subcategories for that category.
So what is that size function is? What is that doing in there?
So it counts the number of matches of this pattern, right? So how many nodes are directly connected through the subcategory of relationship?
It's the subcategory, then supercategory, and then either.
Exactly. And that lists for all the categories, and then I'm doing an order by on the total. So we see that the biggest ones are this category, that's databases by country. So this probably is one of these large aggregate categories in Wikipedia, where then you have actually 30 subcategories, which will be probably database in the US, database in the UK, so that's why it's one of these large. Anyway, that's one possible query that we can run on our data. But probably something more interesting is looking at how balanced the categories are, and this notion of balance is basically how what's the ratio between the the ratio between the subcategories and the supercategories. So as you can see, it's just a division here.
So the first bit's all the same. So it's all just counting the size, and then we're only keeping the ones that actually have sub.
Yeah, basically what I'm doing there is remove the root and the leaf nodes, because they will always return 0 or 1 in the balance, because they only have either child or parent. It's, I mean, probably just an idea of one possible indicator that we can run in a graph like this one. But let's look at another query. We can, for example, run some aggregates. That's an interesting one, because that gives a view on the average number of subcategories that we have, or what's the minimum and the maximum number. So some typical analytics queries that you want to do, you want to run on your data sets to understand, what's the proportion in each of them.
Yeah, and I guess some of these were showing us what we'd already knew from looking manually. So, for example, there are the minimum number of subcategories is 0, which was when we went to, I think it was Ethereum. Right. There was no There was no child, and then.
Well, it was GitHub in our data.
Oh, then it was GitHub, wasn't it? Yeah. Then GitHub didn't have any children, and then supercategories, where you would imagine at some point you reach the top, and there's
since it all started from databases, it would be just a database as one. But if it was
but then there are some. It's interesting. There are some that are under multiple parents, and then what we've got here. This is the 90th percentile. So 90% have 2 or less, I suppose. Yeah,
it's interesting here, because you see the max is 30, but still, it would be probably just 1 or 2 of them that are very, very dense. But And
yeah, because the maximum number of subcategories is 30, but 90% of them have 3 or less.
Yeah.
So there must be like
it is just a few hundred nodes, but when we run these on the whole 1.4 million hierarchy, these numbers are more interesting. But yeah, these are
cool
ways of exploring the data set. And then the example, the GitHub one that we're mentioning, there was one that I had prepared here that was Google Doodles that also appears as a category, but we can try GitHub, right? So we saw it as one of the categories that were loaded up to level 4. But what we can do in Neo is say what's the shortest path between a given category, right, or a given node and another node, and we can specify the pattern that we're looking for. So if we have this node representing GitHub, we know that a number of levels down the category relationship will get to the root category, which is databases. So what's this path? And we can use the shortest path function in Neo, and that should interesting. Did I not?
It might be the H.
Good point.
There we go.
Brilliant.
Always forget the.
Yeah, so
the H,
that's it. So you were wondering what was the connection. So GitHub is an open source software hosting facility, which is a subcategory of project hosting websites.
Which is a subcategory of online databases, which is a subcategory of databases. That one kind of makes sense. Makes some sort of sense.
And I guess if we took that on the Wikipedia page that we were saying before, we can do the whole navigation there.
So what was the other one? Was Google Doodles? Was it?
Yeah, if you can click. Well, if you can Control Z, probably. Yeah.
Oh, probably spelled it wrong.
Yeah, you can click it. Is it that? Oh, maybe it's not been loaded. Maybe it's level 5. No. If we load an extra like that probably requires.
We could try NoSQL though, I suppose.
Oh,
that's not very interesting.
That's an easy one.
But you can also, in case you haven't used this, you can go and navigate around and see what other stuff is there. So we could, there's nothing. These are leaf nodes, so we end this part of the graph ends at level 2, but databases on the other hand obviously expands out to a lot. Well, this is an interesting area of the graph.
Yeah, it can be good.
But yeah, you can probably
other queries we can keep going with the guide. So
got distracted.
No, but some of the things that Mark was mentioning before, we can actually. The interesting thing is we can express it formally with a query, and for example, we wouldn't expect to find a path that's 10 steps long, right? Because we've only loaded like 4 levels.
Yeah.
But if you remember, Mark said before that there are loops and there are connections in all directions. So if we look at that, we run this query. Basically, it's what we, for those of you who are less familiar with Cypher, what we're doing here is we're saying, well, we want paths that are formed by nodes connected through the subcat of relationship, but we want these a number of times. So that's what the asterisk indicates, and we can define a lower and upper limit. So in this case, we said that it has to be at least 10 steps long. Right? Yeah. So we shouldn't have 1 if it was a proper tree, as we were saying before. But it's not the I need probably I didn't load enough levels to point it up to level 5, but still 7. If you think of 7, since we only loaded 4 levels, shouldn't happen. But the reason for that, and let's try to present that in some linear way, but we have databases with 2 subcategories, and the thing is that we find that, oops, let's make that full screen. There we go. So the reason why we have these sort of longer paths is because you can see that there's one that could go this way. Okay.
Yeah.
So it's not a strict tree. That's the thing. Okay. So should we? I was wondering if we should probably load level 5, but to get some more interesting results. But anyway, that's one. What about the loops? Will we find loops with these? Oh, that's not a very interesting one. Well, it's quite interesting actually. Oh, hang on. So we see that there's a category that's data-centric programming languages, which is a subcategory of persistent programming languages, which is actually a subcategory of the other one. I wasn't expecting that one, but probably.
There's only one, yeah. One day
well, I've limited to one, but There's probably more. No, it's only one. Yeah, we probably.
We're missing level 5. Yeah, we can put in level 5.
That's level 5 exactly. Let's do 5. And
oh, I don't think it did it. Maybe.
Oh, it didn't.
Need a space after the
space probably. There you go, and we
yeah,
can.
It still didn't. Oh, unless it's.
Did it not? Oh, interesting. That's a bit.
Yeah, try the colon params again, I guess. Are you seeing it now? Nope. Or what if we're doing it?
Well, I don't know. We should try another one, but well, we can probably still. Yeah.
Okay, that's working. Maybe we're missing something. Yes, it was level 5.
So if we set level 5.
Oh, there we go. Okay,
cool.
Work that time.
So let's bring back the guide, which must be somewhere here. And the query is this one. So if I run it, it should bring level 5. Let's give it a second, and we can go back to our queries on exploring the data sets. There you go. So it's 270 extra. That should probably bring now Google Doodles. There we go. Now we have the Doodles that are connected again to probably somehow unexpected. This is a Google event, which is a subcategory of Google, which is an internet search engine, which is an online database, according to Wikipedia.
Are there any other internet search engines?
Oh,
there's what's that one?
So these are subcategories. So
yeah,
there's Yandex. There's
yeah. So this is, I guess this is the thing I've been getting confused with, is that we haven't loaded pages, deliberately not loaded pages. But it's weird because sometimes you see a category and you're like, oh, surely that's a page, but it's actually a category, and then there's a page with a very, very similar name as well. So, for example, you'd think, oh, Google is a.
Well, there will be a page as well.
So there'd be a page for the
Google as a
company,
page and Google as a category. So here, yeah, that's actually, if we expand Google, there's a number of.
Oh wow, there's loads of stuff under.
And again, these are categories. So
there's my phone up there. Wow, Google Art Project. Okay, there's loads of stuff.
Cool. So let's go back to the loop. So probably. So
just a quick question, or maybe a statement. It says Cypher seems powerful, but a bit scary. So what would you? I don't know if you can cast your mind back a few years. Can you? I think when I first picked it up, I thought it was a little bit. I was very SQL versed, I suppose. So I took a little bit of time to get used to like, oh, okay, I don't do select and from, I've got to do match. And it took me ages to remember that it was a match and where and return. But once I got the hang of that, I quite liked the, I guess that the variable path thing is maybe a bit scary. Perhaps unusual syntax, but.
I don't know, yeah, possibly. I mean, I guess you have to change it, get into this mindset where you describe patterns. Then it's true that, there are other bits like all the standard data manipulation, like aggregates, doing like average, calling these sort of functions. But here, if you think of it or look at some of the queries that we've run, I mean, the key thing is these patterns, the way that you describe how things are connected rather than how, according to which columns tables should be joined. But yeah, well, I guess it's like every other language. I mean, it requires a bit of, hands-on.
I think yeah, we've Hazelus and I sometimes run like evening workshops and meetups in London, and we've found it takes like a couple of hours of really hands-on, like doing simple examples and building those examples up and practicing and trying to break it and see, okay, what if I change this bit of the query? What does that do? A couple of hours of doing that, and most people are kind of got the hang of it and are reasonably comfortable with trying it out on a different data set than the one they've learnt it on. So yeah, I think you're probably all right. It's maybe a bit scary to begin with, because you can really do some quite powerful queries, and it takes a little bit of getting used to. But I don't think the learning curve's too steep.
Cool. So I don't know. I mean, probably at this point, I mean, the plan was to, although we're going to be short of time, but. I mean, the idea, I guess that probably has shown how you can ingest one level at a time portions of the Wikipedia hierarchy through the REST API, through the Wikipedia API using Cypher. But then the other option for if you're interested rather than in a portion of it, you want to load the whole hierarchy. What you can do is use a batch approach. So the Wikipedia, we can have a look at it here, offers you can find the link here. Basically regular dumps of the whole content. So one thing you can do is download these dumps. And in particular, there's one for the categories and the relationships between them, the hierarchy of categories. And these dumps are MySQL dumps, so you can easily load them in your MySQL instance. And then from there, you can run some SQL to produce CSV files, and then load from these CSV files. That's one option. I mean, if you have these CSV files, and I give you a link here to those files as I've generated them. So you can easily run a massive data load of the 1.5 million categories and the 5 million relationships between them. I wouldn't recommend running that in the sandbox, because that's probably a bit bigger than what.
Yeah, so the sandbox is running Docker containers on AWS images, and so they are a bit more memory constrained than what you'd be able to do on your own machine. So for the CSV data set, probably best to download Neo and give it a try locally. And so
so that's what we've done here. So what I have now, I've moved to my local instance, and I've already preloaded all the categories. So we can run similar queries to the ones that we've been running on the smaller data set. Well, they're actually probably worth looking at something quite interesting. So these are just a bunch of the categories that we have in our graph. But you will notice that it doesn't only contain the name of the category, but it also contains two counters: a counter of subcategories and a counter of pages, the number of pages that are tagged with this category in Wikipedia. These are pre-computed ones, so these are part of the dump. So I have not computed them. That's part of the dataset that Wikipedia offers, and so we can probably run some queries on that, as it could be probably interesting. So if you look at it, it's not a very graphic query, because we're basically running for every category, every node in our graph that's of type category. What I'm going to do is a sum, an average, and a percentile, and a minimum and maximum on this page count, and that will give us some quite interesting results. I mean, now it takes a bit longer, but 3 seconds, because it's a larger data set. But if you see, what I've done is I've summed all the pages that are categorized according to the categories in this complete hierarchy. It returns 100 million. That's way more than the 40 million pages in the Wikipedia, but that's because obviously pages have multiple categories. What we have here is just the counter, so I have no way of deduplicating. That's why I mark here that there are some duplicates. Then we have the average number of pages per category, which is 72. Percentile, which is something. You can see that the minimum is -1. I don't know what that means. I mean, data error. So for a data error, that's an aggregate value that comes from the Wikipedia dump. But another thing that we find if we load the whole data set is that there are some orphan nodes, and we find an orphan node in Neo by saying, well, find a category for which there is no subcat of relationship in any direction, so it's not connected to any other one. What I want to do is just get a count, and you'll see that there's around 30,000 of them out of 1.4 million. It's not too many.
Do we then have a look at one of them?
We could, yeah. So you see that there are some.
So some of these categories are.
And you can probably. It might be worth picking
one. Should we try this one? So would that be? It would be like the end of Wikipedia.
You can go
be
to
like that.
Scroll down there.
That?
No, it was the main. We'll go to one of it. Is that a page or is that a category?
I don't know.
Now let's hang on. Let me. So if we go to this one and we replace, did you copy the category that you wanted to look at?
I don't know. Yeah, if it was a category.
Okay, so that's the one.
Oh, there we go. Sorry, yeah.
So that's.
So this one has some pages. No, it does actually have some categories. So
yeah,
we found sometimes in this data dump,
it's not totally in sync with the actual concept of the Wikipedia.
And there are some that are the other way around, where we found there were more categories in the dump than there were on the page. And then there are hidden ones as well.
Yeah, that's probably
beyond what we're going to do. But there's all sorts of idiosyncrasies if you drill into the Wikipedia data.
Right. What more queries can we run here? So we can do something similar to what we did before. So it's finding which are the biggest categories in Wikipedia. So it might be interesting to have a look at these. So you see that I'm considering a big category if it has loads of categories and subcategories, of course. So we see that at the top, so they're not even domain-based, so it's more like this one is...
Oh, this is our favorite one, wasn't it? Wasn't this one?
It has 200,000.
Have you got the... This is the one where you... Yeah, this is actually an interesting one. This is one that's been marked for deletion, but hasn't made its way to the job queue where it can be deleted just yet.
Yeah, actually, from the point of view of the graph, probably is one that we might want to delete manually. I mean, now we don't have the cipher here, but it's a super dense node. I mean, it's compared to the rest.
Yeah, it's got six or seven times more.
200,000 more than that. Yeah. But then if you drill down, some of them make sense. So for example, if you look at the albums by artists, so you have like 20,000 different subcategories under that. So yeah, some interesting one there. So what else? Same average and aggregates that we run before, but now on the large data set we can run it there. And when we get that, we can probably, there you go. So we have the average number of subcategories in the complete hierarchy is 2.8, but the max being these 200,000 that we saw before. Right. So just to conclude, probably just mentioning, we're not going to run it, but there's another option. So once you've downloaded the dumps from the Wikipedia, instead of generating, running this SQL, instead of generating CSV files and running through load CSV, you could also directly run these queries and stream the results into Neo using, again, APOC. So there's the APOC load CSV, load JDBC. That takes the connection string to your database. So here's my local instance. And the SQL, that can be any random SQL. And basically, it will run the query. And instead of persisting the results in a CSV file, it just streams the results, and you can use them to create the categories, and the same with the subcategories below. But we leave that for you to try at home if you want.
And with that, I guess we can we'll probably quickly wrap up. So if I just back in again here. So just a reminder of the link if you want to play around with this afterwards. So guides.neo4j.com/wiki. I don't think we have any questions, so I'm going to go on to our quick closing announcements. But if you have any questions, I'll ask them on the chat or on the Slack, and I will pick them up. So I see Michael's been answering some on there as well. So there's one on the Neo4j Slack about calling APOC procedures recursively, and so you can do that. And probably if you put I think it's Taffy B, if you put your example on there, we can probably Michael or one of us can reply. So just to quickly wrap up, if you're in Europe, or if you can be in Europe, we've got the Graph Connect conference on the 11th of May. We're also doing a data journalism-based hackathon the evening before, so on the 10th of May at Skills Matter. So if you join for that, that'll be quite fun. Our next online meetup is next Thursday, so yeah, next week today. But the time is different, so note this time. Instead of this now was the equivalent of 9 a.m. In San Francisco. So there'll be 4 hours later. So it'll be at 1 p.m. And we're going to have two people that I discovered that we've discovered through the community. So they've both been learning Chinese with Neo4j, and both have got slightly different approaches of doing that. And so Fernando Izquierdo, I hope I said that right, and Diego Rodriguez will be joining us, and we'll be talking through what they've been doing there. So same thing, so sign up on the meetup for that if you can make it. Otherwise, if you liked this, our shameless self-promotion by Jesus and I, if you like this, don't forget to subscribe to the channel so you get notified about any other videos we post. So you may have seen there's quite a cool video by our chief scientist, Dr. Jim Webber, where he talks about the evolution of Neo4j. And if you like this video in particular, don't forget to like it so that I guess we'll get a higher recommendation for other people. I'm going to do a final check off the, and looks like we're good. There's a code on the chat for Graph Connect if you can make that. Otherwise, thank you very much for taking the time to join us, and we'll see you next time. Goodbye.
Okay, bye.